Okay, so we're going to draw representative samples of vectors in this vector field and describe the flow. So again, you'll notice that this is kind of similar to a vector field that's in the section, right? This is a lot like that negative y comma x. It's just y comma negative x, but then it's also divided by the length of the position vector. So it's there's some interesting stuff going on here. And so, for example, you'll note right off the bat that f dot x is still 0, just like in that example that was in the section. And now what's the length of f, though? Well, the length of f ends up being 1. And that's, you can just do a direct calculation because why is that? Well, because f itself is y comma negative x divided by, well, the square root of x squared plus y squared is the length of y comma negative x. So we have something divided by its own length, and so therefore the length of this thing is 1. Okay. So what we have is a vector field that's always perpendicular to position vector and length always equal to 1. So when you start drawing the pictures, I mean, there are two different ways that this could sort of be rotating around, and you have to sort of get it straight which one's which. This point here, right, you have x is 0, y is 1, and so that gives you, excuse me, x is 1 and y is 0, so that gives you that vector. And then there's really only one possible vector field that this could be. I mean, it has to be sort of going in that direction, always perpendicular to your position vector, which means you're always sort of going around the origin, and the length always 1, so it's always something kind of like this. But it doesn't get longer as you go further away. It just stays the same length. Or weirder, it doesn't get shorter as you go inward.
I didn't get. I thought it would change because of the terms on the bottom.
Well, no, it's the terms on the bottom that keep it from changing. It's the square root terms. When you compute the length of this thing, keep in mind you always get 1 because of these terms in the bottom, which are this right here. This right here. Yeah. Does it make sense? Yeah. Right. So it's kind of a strange vector field, and let me just draw a couple more examples here. So, should be longer. So, let's see. It says describe the flow. So I would describe this as being kind of a sort of a little whirlpool, right? Because it's going around, but it's going just as fast in the middle as it is along the outside. And while the speeds are the same, but here it's a tight little loop, so even though it's not going very fast speed-wise, it's spinning around quite fast in the middle. It's the angular speed is fast in the middle, whereas the angular speed is kind of slow around the outside. So it gets sort of kind of maybe sort of a little whirlpool kind of thing. Does that make sense to everybody?